Hello there and welcome to this video on how to complete the square. If you ever have a quadratic that isn't easily factorized but yet you still need to find the x values for some reason, you could complete the square and that will get the x values. Completing the square is more of a method, and the best way to teach you how to complete the square is by doing a few examples. So that's exactly what this video is going to do. I'll take you through a few examples just so you can see how to complete the square, and then once you've got familiar with the method, I'm hesitant to say that there's a general formula for complete the square because there sort of is, but there sort of isn't. I'll show you the quote general formula that you might see, and I'll show you how you get to that, basically the derivation of it, and then I'll show you the derivation of the quadratic formula, and I'll show you that basically when you complete the square you are in essence just using the quadratic formula. So let's begin with our first example. X squared minus 8x plus 5 is 0. It is in the regular quadratic form, so if you do have something that isn't in this form, say it was x squared minus 8x equals minus 5, you will need to put it into this form before we can begin. So the first step that we are going to do is we're just going to focus on the x terms to begin with. And we are going to find an expression for the x terms. So I'm going to begin with x minus, and now I'm just going to half the constant in front of the x term and square it all. If we were to expand this expression out, we would get x squared minus 8x plus 16. So the first two terms, when we fully expand this out, x squared minus 8x, which is what we have at the top, but we've got this extra plus 16. So to make this expression correct, I'm just going to minus a 16 from here and then carry on writing out the rest of the quadratic expression. Collect all of the unit terms. Bring the unit terms to the right hand side. Square root both sides. Just a note, if you notice I've put a plus or minus in front of the square root 11. That's because if we had a negative number that was squared, it would give the same answer as positive number squared. If you had minus 2 squared, you would get 4, but if you had 2 squared, you would still get 4. So unless you know if you started with a minus number or a plus number, you can't really know if the number was a minus number or a plus, so that's why we put the plus or minus there, just to cover all our bases. And from here, all we have to do is bring the 4 over, so we've got x on its own on the left hand side. And that is our answer for the first example. X is 4 plus or minus root 11. What would you do if you had a constant in front of the x squared term? Don't worry, we'll do an example on it and I'll show you how you would tackle that. So let's do a second example. Okay, this is our second example. If you notice, we have a constant in front of the x squared term. So we have 3x squared minus 12x minus 7 is 0. The first thing I'm going to do is focus on the x terms. This time I'm going to factor out that 3. So I'm going to rewrite it as 3, and then I'm just going to write the equation as normal. So 12 divided by 3 is 4, so this will become minus 4x instead of minus 12x, and then write the rest of the equation as normal. And we just do the exact same what we did in the first question to the brackets. But bear in mind and remember that everything inside the brackets is times by 3. This is where a lot of people make mistakes and they forget that everything in the brackets is times by 3. You'll see what I mean as I go through the question. So we're just going to do what we did to the x terms like we did in the first question. I'm going to make square brackets just to again hammer home the fact that everything in the brackets is times by 3. I'm going to divide x term by 2, so I'm going to make this a minus 2. I'll square it. When we expand that out, we get x squared minus 4x plus 4. So in order to express x squared minus 4x, we need to take away this extra plus 4 from this expression. So I'm going to do that and then close the brackets. Yep. And then I'm going to carry on with the rest of the equation. Times everything in the square brackets by 3. You can see in this step why it's important that you make sure that that minus 4 term in the line above is within the square brackets, because you'll end up with a completely different number for the unit terms. So again, I stress that everything in those square brackets is times by 3. Carry on like we did before, we just want to collect all of the unit terms. Bring the unit term to the right hand side. Divide both sides by 3. I'm going to move to the right hand side of the screen. Square root both sides. And remember, we still need that plus or minus there. And we just take the 2 from the left hand side to the right hand side. So we have x on its own on the left. You can leave the answer here, but I don't like having a square root on the bottom, so I'm just going to manipulate this answer a little bit just to get rid of that root 3 at the bottom. And to do that, I'm just going to times the top and the bottom by root 3. In essence, you're basically timesing it by 1, because root 3 over root 3 is just 1. So root 19 times root 3, if I quickly do that, is root 57. And you times root 3 by root 3, you get 3. So the final answer will be x is 2 plus or minus root 57 over 3. We'll do one last example. This one has a minus constant in front of the x squared term, so just do be careful. So we'll go through this one and it'll give you just a little bit more practice as well. Like we did in the second example, just focus on the x terms first. And I'm going to factorize out minus 3. It's personal preference whether you leave the minus there or not. I prefer taking out the minus as well, just because it makes the x squared a lot nicer. You don't have that pesky minus at the front. If you are taking out the minus with the 3, do be aware that this is now a plus. You've taken the minus out here, so a minus times a plus will become a minus. So you need to make sure that this in the brackets is a plus. And then 18 divided by 3 is 6, so this will become 6x. And you can times that out and you can double check that you do indeed get minus 3x squared minus 18x, and then carry on with the rest. Again, square brackets, because everything in the square brackets is times by minus 3. We need to find an expression for x squared plus 6x. So x, it's plus, so plus here. Divide the constant by 2, so 6 becomes 3. All squared. When you times this out, you will get x squared plus 6x plus 9. So we need to minus that 9 to make the expression correct. Close the bracket and then carry on with the rest. Times everything inside the brackets by minus 3. Minus times a minus is a plus, so this becomes plus 27. Collect all the unit terms. Move the unit terms to the right hand side. Divide by minus 3. Again, be careful of your signs. Square root both sides. Okay, I'm going to do a little manipulation with the square root on the right hand side. We can rewrite 8 as 2 cubed. Yep, so in essence we have 2 times 2 times 2, or root 2 times root 2 times root 2. If we times 2 roots together, we get the actual integer. So I'm going to take the 2 outside of the root Okay, we also have the root of a negative number. For those that don't know, if you have a root of a negative number, this is an imaginary number. So I'm going to bring the I outside and we can get rid of the minus in the root because I times I is minus 1. So I'm just bringing the minus 1 outside. And again, I don't like having a root 3 at the bottom, so times everything by root 3 over root 3. And then just take the 3 on the left hand side to the right hand side, so we have x on its own on the left. And that is the end of the third example. I put this example here specifically because if you notice, we have an imaginary number in the answer. If we didn't take care with our signs as we went through the whole solution, you might not get that at the end. You might not realise that it is an imaginary number. So this is a good example just to show you the importance of signs. If this is going a little bit too fast for you, do feel free to rewind the video, watch how I've done it again, just so you can get used to the method. But if you are feeling confident, we can move on to, I'm hesitant to say the general formula, but the general formula for completing the square. Okay, so I've just written out the general form of a quadratic equation, ax squared plus bx plus c, where a, b and c will represent a number. Again, I'm hesitant to say it's the general formula because it's more of a method, but I know for the GCSEs they give you a formula for completing the square. Just use the method, but if you are asked to use the formula, I'm going to show you where the formula comes from. The reason why I did the examples first is because once you're familiar with the method, you will see with ease where this formula comes from. So I'm going to start with this generalized quadratic equation, and we're basically just going to do the method that we did in the examples. We're just going to complete the square, use that method, and it will give us a general formula. So we begin by focusing on just the x terms. I'm going to do it in a slightly different way from what I did before, but in essence it is the same thing. I'm going to start by dividing everything by a, just so I don't have that constant in front of the x squared term. Okay, and we can just carry on like we did in the first example. Focus on the x terms, so the x squared and the x term. We need to find an expression for x squared plus b over ax. Like before, we want to half the number, or half the number in front of the x term, so b over 2a all squared. So when we times this out, we will get x squared plus b over ax plus b squared over 4a squared. So we need to minus this extra term, this b squared over 4a squared, to make this expression correct. And then we carry on with the rest of the formula. So that is basically the general expression that you might see. You might not see it with an a sometimes, so it might just be x plus b over 2 all squared minus b squared over 4 plus c is 0. That is just because they haven't started from a equation that has a term in front of the x squared term. This form here is correct for any quadratic equation, so that is what you might call the general formula for complete the square. I did mention at the beginning of the video that when you complete the square, you are in essence just using the quadratic formula, and easiest way to prove that is to derive the quadratic formula, and I can actually do that carrying on from where we left off here. Okay, so I've just cleared the screen, give me a little bit more room. I'm now going to derive the quadratic formula, and I'll show you that when you complete the square, you are basically just using the quadratic formula. First things first, I'm just going to put all of the constants, so the b squared over 4a squared term and the c over a squared on the right hand side. You notice we're basically using the same steps that we did in the complete the square method. We're just not using any numbers, we're just leaving all of the placeholders there. So let's do that. do be careful of your signs. I don't like the right hand side, it's a bit messy. It would be nicer if it was all over the same denominator. So that's exactly what I'm going to do. I'm just going to express c over a in a form where it will have the denominator 4 over a squared. So to do that, if I times the top by 4a, okay, so just times the top by 4a. If you notice, if I were to cancel it down, the 4 would cancel and a would cancel and you'd be left with just c over a. Square root both sides. Now we want to have the x term on its own on the left, so we're going to bring that b over 2a term to the right hand side. Oh, I forgot my plus or minus here. And that is the quadratic formula. If you go back through the steps of how we got to that formula, you'll notice that it's the exact same steps that we did when we completed the square. And that is true, it is the exact same method, just when you do the complete the square method, you put the numbers in at the beginning, and then you cancel as you go along. It's just nice to see where the quadratic formula pops up from complete the square, just to further prove my point. Look at the format of the quadratic formula and you'll see that you have a number plus or minus something in a square root all over a number. Look back at your answers from the examples and you'll see that the format of the answers is this format here, mostly this format here, with a bit of manipulation anyway. That's the end of this video for today. If you feel like it's a little bit too fast, do feel free just to go back, rewind, and if you still are struggling with complete the square, type in the comments below and I'll go through a few more examples. But I hope this helped and have a nice day.